previously, we talked about when we find your different possible permutations, that's when your order is important. So if you have a set of elements, and if your order is important, you have permutations. Then we also have when your order is not important, that is when you can take a combination. So not the combination lock, just a combination. So the way we can talk about a combination is this formula. If you have n factorial over n minus r factorial, now your permutation didn't have this extra r here at the end. With the combination, you have this extra r. So the reason this is important is because for letter A here, this is how many different ways can two letters be chosen from the letters A, B, C, D, E, F, G, and the order of the two letters is not important. So if the number of your letters is not, or the order is not important, that means you're going to end up and have a combination. So if we have a combination, that's using the formula of n factorial. Oh, that's an ugly line there. Over n minus r quantity factorial times an r factorial. So let's look at our numbers. Well, we have a total of 1, 2, 3, 4, 5, 6, 7 numbers. So we're going to have a 7 factorial up top. All over. Well, we're going to try to find the order of two letters. So we're going to say 7 minus 2 gives us a 5 factorial. That's 7 minus 2 times your r. Well, your r is, take an r at a time. So r is 2. So we know that if you have a 7 factorial over a 5 factorial, that just leaves you with a 7 times a 6. And then we're going to divide that by a 2 factorial, or 2 times 1. That gives you a 21. So the different combinations when the order is not important is 21 times. So let's look at letter B. And for letter B, it says we have a certain experiment where 4 students are randomly selected from a class of 20. How many different groups of 4 students are possible? This is where it doesn't say anything about where it's they're important or anything, so it doesn't say whether they're distinguishable. These are a combination again. So we're going to find our, what do you call that? A C. We have a total of 20, and we're trying to choose 4 out of there. So we can say, well, we have a 20 factorial. And on the bottom, we're going to have our n minus our r. So you have a 16 factorial times your r. Now some people like to say, oh, well, that's 16 plus 4 is 20, and 20 divided by 20 is 1, so we get one way. How about no? When you simplify this, you end up getting a 4, 8, 4, 5. So that should help you figure out how many different groups of 4 students are possible if you have a class of 20. Small number. So that's going to wrap up 8-5 counting probabilities, permutations, combinations. I hope you had a great day in this mathation nation.